Okay. Good morning, class. Catherine, have a seat. At this point, we're still busy with our 3D problems. Hopefully today, I think it would be our last lesson. Thereafter, we will go into what? What's the next topic? Inverse functions, graphs. Give paper 2 a break, and then we're going to come hard back at paper 2 again.
So when we're doing calculus?
Calculus after inverse functions. After inverse functions. Inverse functions should take us 4 periods. Yeah, but then again, you guys must be different most to everybody else. That's why we're so behind. But okay, we should catch up. So you guys went on Saturday?
Yes.
How was it? Who was your maths teacher?
It was another guy from the northern suburbs. He was the only one.
He's the only one from the northern suburbs.
Yes. That's what he told
What's his surname?
He's not nearby. What's his name?
He's from Adams College, sir.
Oh, Mr. Khabir.
He's from Adams College.
That's a physics.
The physics teacher is Mr. Kumandan.
Yeah.
The Indian guy. Nice guy.
Oh, he also was our maths teacher.
Yeah.
And then I was like,
What?
he also was our maths teacher, so he said, body, and then the others were like, I think so.
But I know. Mr. Kumandan. He's nice. And the maths guy?
He's very nice also. He taught us calculus.
What's his name?
Forgot.
How can you forget? Alright. Let's just get the textbook open quickly. Which page are we on? 121. So when it comes to calculus, you guys are going to teach the class, and I'll sit at the back end. No? Yeah, because you guys must did it now. Then we can see if you guys understand or didn't understand or misunderstood or spot on. Don't you think that's fair?
Okay, so
You take on the challenge. Nice. I like it. Why must it always be about money to you? Alright, why is number 4 on the board? What was homework? The odd numbers, huh? No, the odd numbers. So I decided to do a few even numbers before the bell rang. If I'm not mistaken, huh? So we did odd already. Okay, relax your bones. Just tell me, then I accept. So I must do number 4. Right. 4 and 7. Okay. So 4 is on the board, I must still do 7. Okay. So let's just do what we have. Work with what we have. No? So we are told that in the diagram, Amy and Bhuti stands 200 meters apart at A and B, which are in the same horizontal plane as D. So we assume that that's on the ground. Well, we know it's on the ground. Okay. Then, they both observe that the angle of elevation of a balloon C from A and B is 48 degrees. So in other words, this angle here is 48, and that angle is also 48. Can you see that, people? The question says calculate the height DC of the balloon above the ground if CAB, this angle is 64 degrees. CAB 64. Okay, so basically what we need to consider here is that triangle ACD. This triangle here is exactly the same as that triangle. Not so? Why? It has a common height, which is CD. It both has your 90 degrees here, and both has 48 there. So in other words, we have a triangle looking like this. That is CD, A, that's 48, or CD, B, which is also 48. So what can we say about those two triangles? The two triangles are congruent triangles. Not so? You'll see now that's going to help us. So we say that is equal to triangle BCD. Why? It's congruent because we went with angle side. Now since that is the case, we can conclude now that AC has to be equal to BC. Not so? Not so? So AC is equal to BC. Why is that the case? Why is that the case? Because the triangle ACD is congruent to triangle BCD. Okay. So how is that going to help us? That's going to help us because this triangle now, we put here in triangle CAB. You have a triangle looking like this now. That is equal, which is CAB. Can you see those lengths are equal? Which make the 64, 64. Okay? So I can calculate this angle C. So I can say that ACB is equal to 180 minus 2 times 64. Which is 128, which is 60, 52. Just check that. Is that 52 correct? Alright, so this angle here in other words is 52 degrees. Okay? So why am I going with that? I'm going with that because now I can calculate, remember this is now 52. Oh, I didn't actually have to do that. No, you actually did. Because I was thinking of the sine rule now. The sine rule is going to use an angle on the opposite side. The cos, I could have used the cosine rule here as well. But the cosine rule is going to be a bit more complex. Okay, so I'm going to go with the sine rule. So I'm going to say that sine 64 over, so I go sine 64 over CB is equal to sine of 52. I must use 52 because I have 200 there. Alright, so I cross multiply. Forgot to pull that, what's the name down? Where's it? Alright, so that would be CB sine 52 is equal to 200 sine 64 divided by sine 52 both sides. So CB is equal to 200 sine 64 over sine 52. Okay. So that's going to give us 200 sine 64 over sine 52. That's going to be 228, comma 1, 2. Okay, and that is meters. Okay, you guys understand? Then we have but we haven't answered the question. So if we look in triangle, this one here now, which is CDB. We have a triangle looking like this now. Again, you don't have to draw this and write which triangle you're working in. Okay, this is making it a bit easier once you follow later on. Okay, so that is going to be 48 Yeah, 48. Remember they want the length of CD. But we worked out BC to be what? 2 to 8, 1, 2. You see that, people? So that is going to be opposite and adjacent, which is sine. So I say sine of 48 equals CD over hypotenuse, which is 2 to 8, 1, 2. I cross multiply, so CD is equal to 2 to 8, 1, 2, sine of 48. Alright? And that now works out to be, in the calculator, answer sine 48. 169,52. Meters. Is that correct? Huh? Just check something confirm. Sorry?
Yes, sir.
Yes, okay. Now I feel a bit better. Let's do the next one. Number 7 you said, no? So you're off now for 2 weeks, no? You're not going in 2 weeks, for 2 weeks now.
Just for one, sir. This Saturday. Wait.
It's 2 weeks, man. Just check again. Okay. So I'm at Rylands.
You go to Ryan, sir?
Yeah,
So don't you think probably accept it?
I do. I go both places. So after here I go to Rylands for 2 hours.
Why don't you come to Oakland, sir?
They got better teachers at Oakland. They put the weaker ones that side.
So you can.
Yeah, part of the weak ones. Alright, so in the diagram, BCD lies in the same horizontal plane. So again, we're assuming this is the ground. Then we are told that AB is a vertical pole. The angle of elevation from C to A is 41 degrees. So this angle here is 41. BCD is 54 degrees, which is this angle there. BDC is 48 degrees. And BD is 36 meters there. BD is this thing. The question is calculate the area. So you must calculate the area of BCD. BCD. So basically you must calculate the area of this. Alright. So according to what I can see, I think we're shorting something. We have, for the area of that triangle, we need 2 sides and an included angle. Okay. Just see what angle CBD works out to be. What's 180 minus 54 minus 48? Work that angle out. Let's see. Sorry? 78. You sure it's 78, no? Let's read again. In the diagram, B, C and D lies in the same horizontal plane. AB is the vertical pole. The angle of elevation from C to A is 41 degrees. Angle DCB is 48. BCD is 54. BDC is 48. BD is 36. Calculate the area of triangle BCD. BCD. 78. So in other words, there is no other way but to use the sine. Because I'm thinking of a different way, but I don't see any other way. I need to use the sine rule. Okay? We need this angle here. Why? Because what I need, I can actually use the side. CB. Yeah, CB. It's going to be easier. So, in fact, I don't actually need this. I'm going to take it off. So we're going to say that CB over sine 48, CB over sine 48 is equal to 36 over sine 54. So you cross multiply. So that would simply be CB sine 54 is equal to 36 sine 48. So CB is equal to 36 sine 48 over sine 54. Okay. Remember, if the length is on top, if you go with sine A over A is equal to sine B over B. If you go with A over sine A, then that must be B over sine B. Okay? So punch that in, let's see what we get. Let's see. So it's going to give you 36 sine 48 over sine 54. So it's 33,07. 33,07 meters. Okay. Okay, I actually needed angle B anyway. So CBD, what did that angle work out early on to be? 78. So that, as you can see, we have two lengths and included angle there. Can you see that? Two lengths and included angle. So the area is equal to a half AB sine C. So it's going to be 33,07 times 36 times sine of 78. Put that in the calculator. So half times that answer, which was the last answer calculated. 33,07 times 36 times sine 78. That gives you 582. Check if that's correct. 582, thank you. 23. That is in meters squared, since that isn't given in meters. Okay. Then they want to, in 7.2, 7.2, it says calculate AB, the height of the tower. So that is, I'm going to go with that triangle here, because I don't have an angle there. Okay, so it's in triangle ACB. You have a triangle looking like this, that is 41 degrees. This is 33,07, that is your 90. And they want you to calculate AB, the length of AB. So which trigonometric function would I use there? With opposite and adjacent, you're going to use tan. So tan of 41 is equal to opposite, which is AB, over 33,07. Opposite of adjacent, so you cross multiply. So AB is equal to 33,07 tan 41. Okay. So we go 33,07 tan 41. You 28,75. Is that correct? Alright. So that basically brings us to the end of this exercise. Alright. People, there's definitely a sum like this in your upcoming cycle test. Okay? If I'm you, I would spend some time on it. The sum is worth 12 marks. Okay? Some of you will say, only 12 marks? I don't need those 12 marks in my life. No? Oh, you just keep quiet, one of the two. Alright, let's do this worked example here.
So we're not marking the homework.
Huh?
Are we not marking the homework?
Didn't we just mark the homework now?
No, I thought someone said you must remind to do it.
So what was the homework?
Exercise 1, and exercise 3.
Okay, at the end of it I will send you a memo to this. Is that okay? So I need to wrap this up today so that we can start inverse functions tomorrow. Okay. Otherwise, we're definitely not going to make the. You see, I'm moving slowly with you guys, man. That's why. And we're doing a lot of examples because you people don't talk to me. So I don't know if you understand or not. So I just assume you don't understand. That is why I'm doing so many examples. But when I marked the test and then it looked like I was doing the examples by myself. And you guys didn't do homework and things like that. But I would like to believe I'm wrong, man, you understand? No, am I wrong? Oh, yeah. Again talking to myself, you see? People think I'm crazy. But it's fine. You guys are one in a kind group, no? You guys are special. People, this is the example on page. Which page is this on? Sorry? One 28. Right, here we are told, okay, now these are examples with unknown angles or variable angles. Can you see that? It's unknown angles. So we are told that in the figure B, C and D lies in the same horizontal plane. Then we are told that AB is a vertical pole. That means you say that's at 90 degrees. The angle of elevation from D to A is 60 degrees. Then we are told that BC is equal to X, which is that there. Then we are told that CBD is 30 degrees. Then we are told that BDC is theta. You must prove that BD is given as that there. Okay. So again, that is what we need to prove what BD is. So I cannot use that in my proof. I must end off concluding that BD is equal to x over 2 into the root of 3 plus 1 over tan theta. You guys understand? Do not write that down on top. Okay? So we go and start here immediately. We say 1. So if you look at BD is this length, which is also the link between the two triangles. Okay? So when we work this out, we always look at what is the link between the two triangles. And in this case, it's BD. But BD is the subject of the formula. Okay? So in other words, it looks like I'm going to work in both triangles. Why? Because they got the root 3 which is coming from the 60, and we got the tan of theta that's coming from there. Okay? And they have the x. So yes, definitely in both triangles we need to work. So let's go with the easier one first. So let's go with in triangle ABD. We have a triangle looking like this. Again, you don't have to draw this on the side. As I said before, for the learner that can't visualize what's happening, we draw this here on the side. Okay. Do I need that? BD. We have an x on BC. Nope, we can get that the root 3 from this one here as well. Okay. So that's going to take us nowhere. So let's look at in triangle BDC now. We have a triangle looking like this. Here's your theta angle, BDCX 30. Alright, which rule are we going to use here? Sine or cos? Sine rule. We can say that sine theta over x, this angle over its opposite, is equal to. Now this angle here we need, not so. Why? Because I want to use BD, its opposite side. So we just take that off again. To work out angle C, it's going to be 180 minus 30 minus theta. Not so? It's the same as 180 minus 30 plus theta. You all agree with that? The reason why I'm not saying it's 150 is because then I can use the reduction formula, 180 plus, 180 minus, or so on. You guys understand why I'm not simplifying this here, no? So now we can say that it's going to be sine of theta over x is equal to sine of 30, not 30, sine of angle C, which is 180 minus 30 plus theta, over BD. So what I do is I cross multiply. So BD sine theta equals x. Now 180 minus an angle is in which quadrant? Quadrant 2. Is sine positive and negative in quadrant 2? Positive. So it's going to be sine of theta plus 30 or 30 plus theta. But what do they want on its own? BD. So I divide both sides by sine theta. So BD is equal to x sine theta plus 30 over sine theta. But is that the same as what they want us to prove here? No. So what I'm going to do is I'm going to take sine of theta minus plus 30 and do the sine expansion. Okay? So I do the sine expansion. So that would simply give us, open brackets, sine theta cos 30 plus sine 30 cos theta. Okay. So what we do now is we put each one of its own. So BD, I'm keeping x outside. The reason for that is, as you can see, what we need to prove, x is outside already. So that now gives us x into cos of 30 is root 3 over 2 sine theta plus sine 30 is 1 over 2 cos theta all over sine theta. Yes, we said each one of its own as well, no? Over sine theta, sine theta. So what do you notice here? You should notice that a half is a common factor. Can you all see that? Take that out, becomes a half x, or x over 2, into Sine theta cancels sine theta, leaves you with the root 3 plus that half is now gone. And what is sine of a cos? Sine of a cos is 10. And cos of a sine is 1 over 10. Which is 1 over 10. And they have proven what they wanted. A sum like this is worth 5 marks. Okay, minimum of 5 marks. There's 1, 2, 3, 4, 5, 6 marks. 5 to 6 marks. Okay. People, this work doesn't come easy. As I tell you many times, maths is easy. Okay? But this doesn't come easily. You need to sit and practice this a lot for you to see it. Once you can see it, and once you get in the sums right all the time, you will get it right in the exam. But you won't figure this out in an exam. Okay? You must sit with it, you must practice it. Okay? Yes?
So why isn't the x over sine theta also?
Sorry?
The x is just...
You see, if I got x into 2 plus 4 divided by 2, this would be 6x over 2, which is 3x. Not so. But now if I do what I did there, I put each one over its own. No, that's what I did. So it's going to be x into 2 over 2 plus 4 over 2, which is x into 1 plus 2, which is 3. 3x, which is the same. So this is what we call factors. Okay? So if you divide that factor, it will be the same as dividing the whole factor. Okay? Okay, anything else here? Alright, so because of the space, I'm going to take this off. Then they want us to prove with regards to the area. The area can be written as that. Let's remember, I actually need to know this here. So we have proven this already. Alright. Now this didn't happen in a long time now, so let's play along. We are number 2 now. Okay. So at this point, remember we had C to be 180 minus theta plus 30. No? And we got BD to be that. Then they want us to prove that the area of triangle BDC, so BDC, can be written as that. Okay. So you see as an x squared. So which angle do you think they're using in this triangle? Sine of which angle do you think they're using it? Sine of 30. Why? Because there's not another theta here, there's an x squared, so they're picking up that again by the looks of it. There's not another theta, so that comes from this length, the tan theta. That x, we have that 30. What is the condition for the use of the sine of the area rule? It's 2 lengths and an included angle. So, as I highlight today, that will give us 2 lengths and an included angle. So we say in triangle BDC. Again, you don't have to draw this. I'm just doing it for convenience sake. It's going to be B30. Remember, that is what BD is, and angle C, and there's your x. Okay, so we're going to say the area is equal to a half BC times BD, sine of angle DBC. don't also have to write this down. But you say it's going to be a half x times BD, which is the story here, x over 2 into the root of 3 plus 1 over tan theta times sine of that angle, which is 30 degrees. Okay? But sine of 30 is what? What is sine of 30? A half. Not so? So in other words, that would simply be half times x over 2 times that half there into the root of 3 plus 1 over tan theta. Okay? So what's x times x? X squared. What is a half times a half? Quarter. Quarter times half? An eighth. Into the square root of 3 plus 1 over 10 theta. And that's what they wanted us to prove there. Okay? Are you still writing? Okay, right. Okay. Right, so we have that also sorted at this point. And the last question, we are asked to prove that AB is equal to this here. Okay, I don't think we need that one. So we must prove that AB is equal to that there. So if we look at which triangle AB lies in, is in ABD. Can you see that? So in triangle ABD, there's 60, there's ABD. But what is the length of BD equal to? That's story there. Can you see that? So which trigonometric function uses opposite and adjacent? Tan. So now you say tan of 60 degrees equals opposite, which is AB over BD. Since I want AB as the subject of the formula, you cross multiply. So AB is equal to BD, tan of 60. Now as we said, BD is the story here. So it's x over 2 into the root of 3 plus 1 over tan theta times tan of 60. That now takes us to the special triangle. So it's 1, 2, root 3. There's your 60. Tan is opposite over adjacent. So it's going to be root 3 over opposite over adjacent. Root 3 over 1. Yes. So if you investigated what you have here, what do you notice? Whatever is outside, it's still on the outside. Not so? So what must happen to root 3? Just multiply this in. That will give you x over 2 into root 3 times root 3? 3 plus root 3 over tan theta. And there's what they wanted you to prove. Okay. We've got 10 minutes left. I'm going to try and squeeze another one in before we leave today. Okay. Before the end of this lesson. I'm going to do number 3 from the from the homework. Sorry. Number 3 from exercise 4. Number 3 from exercise 4. So for homework is exercise 4. Okay? The revision exercise, test topic 6 for the Monday that follows. Okay? That's a hand-in assignment. Okay? Who's putting this in the group? Who normally puts the homework in the group class? Don't you guys put the stuff in the group? Weren't you doing that, Ashley? Were you putting it initially in the group? Are they not in this class anymore? No, Kay was here last year, man. Is it? Oh, and yeah, I'm thinking, why didn't you guys do your homework? It's because nobody's putting it in the group. Oh, okay. Doesn't Kay want to come back? There's also a common diagram that is given in the exam. Okay. So let's see what we can do here. The whole exercise. So the day we have time, we will do then the problems that you have with exercise 3 as well as the revision exercise. Okay. As we're going to do with the next with that analytical geometry that we need to wrap up still. Okay. That will be in one lesson, 1 hour lesson. Okay. Right. So this is number 3 out of exercise 3, page 4. Nice. Exercise 4, page 129. Right. Let's bring this Mickey Mouse down a bit. Right, so we are told that in the diagram in the diagram BC and D lies in the same horizontal plane. AB is vertical to the plane, which means to say it stands 90 degrees. Then we are told that AD is 2P, which is that length. Then CD is P. CD is P, yeah. Then we are told that ACB is theta. Nice. Then we are told that ADC is 2 theta, which is that angle B. Question says, show that. The question says, show that the area of triangle ADC, ADC is denoted by the, right, so what do we say? We start off by saying in triangle ADC. You have a triangle looking like this. There's 2 theta, ADC, we got 2P and a P here. What do we need for the area rule? 2 lengths and included angle. Do I have 2 lengths and included angle? Yes. So we say area of triangle ADC is equal to a half AD times DC sine of angle D. So that's simply a half times P times 2P times sine of 2 theta. Now it feels like I've done the job, no? But if you look at what is given here, that is not the case. So what must change here? Sine 2 theta. But sine 2 theta can be written as what? 2 sine theta cos theta. So that, if you simplify this here, that would simply be, the half cancels 2, so it will be p squared times 2 sine theta cos theta, which is 2p squared sine theta cos theta. Okay, so that was fairly simple. Let's look at the next one, 3.2. In 3.2 they want you to look at, or to prove that AC, again, AC is equal to P, the root of 9 minus 8 cos squared theta. So of course we can work in that in this triangle here, or the triangle that we've worked in before. Not so. But which triangle do you think we're going to work in here? In triangle? In triangle ADC. Well done. At least you can see that. We now say that, why do we think we're going to use this triangle here? Because we have two lengths and an included angle. Which rule is going to come into play here? The cosine rule, the cos. Okay. So what do we say here? We say AC squared is equal to AD squared, you don't have to write this down, plus CD squared minus 2AD times CD cos of angle D. So it's going to be 2P all squared plus CD, which is P squared minus 2 times 2P times P cos of 2 theta. So this simplifies to be 4P squared plus P squared minus 4P squared cos 2 theta. So we're going to take the square root of AC here. Is that going to look like we have what we have there? No. What do we need to change here? We need to change. So remember that 4P squared plus P squared is 5P squared. No? But what needs to be changed here? Cos 2 theta. Not so. Which one of the three we're going to use here? For those of you who put in your face, what three am I talking about? That cos 2 theta can be written as one of three, the double angle, which is 2 cos square theta minus 1. 1 minus 2 sine square theta, and cos square theta minus sine square. Which one of the three are we going to use there? The first one. Why? Because you see there's a cos there. Okay, so that's going to be 5P squared minus 4P squared into 2 cos square theta minus 1. So what are we going to do now? Get rid of the brackets. So that gives us 5P squared minus 4P, not 4, 8. 8P squared cos square theta plus 4P squared, which gives you 9P squared minus 8P squared cos square theta. What do you notice? What is common here? P squared, which I took out there as well. Can you see? So it's going to be P squared into 9 minus 8. Those are doing taking out the common factor here. So the common factor of P squared, you are left with 9 minus 8 cos square theta, which is AC squared. So what do I do now? Square root. Not so. So AC is equal to, if I take the square root of P squared, I'm left with P root 9 minus 8 cos square theta. And that's what they wanted us to prove.
Your attention, please. One way will meet in the hall now at break. One way will meet in the hall now at break. Melissa Pulingani, can you please report to the office? Melissa Pulingani, please report to the office.
Okay, so let's just wrap up the last one quickly. So remember now AC is also equal to that thing. Okay. Then the last question, which is 3.3. They want for you to prove that, to show that AB, which is this length here, can be denoted as, or can be written as P sine theta into the root of 9 minus 8 cos squared. Now you see this part here, that plus that P is coming from AC. So that is how I know I must use AC. Can you see that? So in which triangle are they working in? In triangle ABC. So I have a triangle looking like this. The right angle triangle, BAC, is 90 theta, and that was AC. So which trigonometric function uses opposite and hypotenuse? Sine. So you say sine theta equals AB over AC. So that is naturally over 1, so cross multiply. So AB is equal to AC sine theta. But remember that sine AC was proven to be that there. So I replace AC with that, so it's going to be sine theta times P root 9 minus 8 cos square theta, which will now give me P sine theta root 9 minus 8 cos square theta. And they have just proven or shown that AB can be written as that. Okay? Again, people, as I've told you before, this is not going to come to you in the exam or as a revelation in the exam. You have to practice this. Okay? Don't forget this work or the revision exercise as well as exercise 3 or 4, sorry, is due for next week Monday. People enjoy the rest of it. Monday's holiday. You don't even tell me. Okay, Wednesday. Is that okay? So it's a whole week and 2 days. Enjoy the rest of your day. Good morning, class.